Hi guys, today we are going to be talking about properties of inverse functions, and then we are going to look at two functions and then make the call if they are inverses of one another. Okay, so from the top, the inverse of a one-to-one function f. So what's so special about f? Not only is it a function, it has to be a one-to-one function. Okay, so if f is a one-to-one function, then the inverse may exist, which is denoted by f, which kind of looks like f raised to the negative first power, but this is actually the notation for inverse. So this is read as the inverse of f, or just f inverse. Okay, now let's go ahead and look at those properties. So if f is a one-to-one function, then the question is, how do we find the inverse? Okay, so to find the inverse, or f inverse, we are going to reverse all the ordered pairs in f. And I'm going to expand on it in a bit. I'm not sure if in this example or in another one, so we'll see. Okay, so I guess we're going to do it here. So let's just say that we have f, okay, and we have some ordered pair in f. What would be the ordered pair in the inverse? Okay, so to find the inverse, we're just gonna go ahead reverse all ordered pairs in f. So when we switch these two, that will give us BA. Okay, so the moral of the story is this: if AB is in f, then when we switch places, because we're reversing the order, then BA will be in the inverse. So on that note, the domain in f becomes the range in the inverse, and the range in f becomes the domain in the inverse. And then a fun fact, which we will illustrate in a later example: if we were to graph these, then the graphs of f and its inverse will be reflections of each other about the line y equals x. So the main objective of today's video is determining if two functions are the inverse. But now, what are the properties of inverse functions? So we are given the function f. If the inverse exists, then what has to hold true? Well, when we find the composite function f of f inverse of x, that always has to evaluate to x. And then when we find the composite function going the other way around, f inverse of f of x, that also has to give us x. If it doesn't simplify to x, then guess what? The functions are not really inverses. Okay, so in our first and only fun problem, it reads, are f and g inverses of one another? Please answer algebraically. Do not use a graphing calculator to answer. The reason why we have do not use a graphing calculator to answer is because you can easily just graph these. You know, you graph this first function, you graph the second function. If it appears that the graphs are reflections of each other about the line y equals x, then you don't have to do any algebra. You just say, yeah, they're reflections of each other. So we got to do it by hand. Now, if f and g are indeed inverses of one another, then when we find a composite function forwards and backwards, they should both simplify to x. And if it doesn't, then guess what? These guys are not inverses. So let's go ahead and do this one at a time. So we're going to find, or I should say verify. Verify that f of g of x equals x. And if that's the case, then we'll go the other way around. Okay, so we have f of g of x. So the question is, well, what is g of x? Okay, so g of x, I need a break again. F of g of x. Okay, so this is what we wanted to verify, and I wanted to start off on a clean slate. Okay, so g of x, according to the problem, is a cube root of, where am I? Cube root of x minus 4 plus 3. Cool. All right, so we want to verify that f of g of x simplifies to x. So let's go ahead, find that, and see if it really does simplify to x. So you can work your magic, substitute cube root of x minus 4 plus 3 for the input, but this is a lot for me, so I need a pause. We're going to go ahead, write down the function f. So function f, so f of x equals, according to the problem, cube of x minus 3 plus 4. And then with confidence, I'm going to go ahead and write down what we're trying to find. Okay, so we want to find f of, it's pretty brutal, but we got this, cube root of x minus 4 plus 3. So the reason why I always write down the function that I need to is because this going up and down action doesn't really work for me. Okay, so what are we gonna do? We are gonna substitute this pretty long expression, sorry, for the input of x. So wherever we see an x, we're gonna substitute this expression, so namely here. Okay, so that will give us, open parenthesis, we have x, which we're swapping out for cube root of x minus 4 plus 3. So cube root of x minus 4 plus 3, who hopefully didn't put the plus sign too close to the radical. Okay, and then what else do we have? I lost my place because I looked up. Okay, that was just x, so I need my fingers. Okay, that was just x, and then we're gonna subtract from it minus 3, and then we're gonna close the grouping symbol, cube it, and then add 4. So let's go ahead, cross fingers, and see if that indeed does simplify to x. Okay, when we combine the like terms within the grouping symbol, sum of 3 and negative 3 will give us 0, or we say they cancel out, and that will leave us with cube root of x minus 4 raised to the 3rd power plus 4. We take our time, index is 3, power is 3, so they undo each other, and that will leave us with x minus 4. That will leave us with the radicand. So that will leave us with the radicand of x minus 4, in this case increased by 4. Sum of negative 4 and 4 will give us 0, and that will give us with x. So look at that. So if f and g are indeed inverse functions of one another, then when we find the composite function forwards and backwards, that should simplify to x. So we already did the first part. Now that doesn't mean that it's also going to work out for the when we go the other way around, but we have to show it, prove it or disprove it. So now we want to verify that the composite function going the other way around, we did f of g of x. So now we switch places. We want to find g of f of x and verify that that indeed also gives us x. So let me go ahead and write down our problem. I learned my lesson earlier. So we have g of f of x. So that will give us g of whatever f of x is. So remember, when we do the composite function, we pretty much substitute like one function into the other. So we have f of x. That's a pretty long function, but we got to do what we got to do. So that will give us cube of x minus 3 plus 4. So what we are gonna do, we are gonna substitute this expression for the input. But again, me going up and down, that bobblehead action doesn't really work for me. So I'm gonna take a little pause, not a real pause, a visual pause. We're gonna write down function g. So g of x equals cube root of x minus 4 increased by 3, and then with confidence we're going to write down what we were trying to find, which is g of this cool expression, cube of x minus 3 plus 4. Fantastic. So now to evaluate this, we are going to substitute this expression for the input of x. So wherever we see an x, we're going to swap it out for cube of x minus 3 increased by 4. Fantastic. So that will give us cube root of x, which we are swapping out for cube of x minus 3 plus 4. Okay, the rest of the radicand, we have a minus 4. Let's go ahead and extend the radical, and then the rest of the expression will give us plus 3. Let's close our fingers, because if it does give us x, I'm gonna feel so validated, like I did the work for something. And if it doesn't, it's okay. Then we just tell the greater than, no, they're not they're not inverses of one another. Okay, so let's go ahead, continue to simplify. Sum of 4 and negative 4 will give us 0, or we say that cancels out. And I know you guys can do a lot of stuff in your head, but I noticed that when I make mistakes, it's not so much that I don't know how to do it. It's just I try to do too many things in my head, and if I don't write it, I don't see it, and that's when I make silly mistakes. All right, coming back to our problem. Okay, so index is 3, power is 3. They undo each other, and that will leave us with the radicand of x less 3. Bringing down the rest of the expression, plus 3, and look at that, how exciting. Sum of negative 3 and positive 3 will give us 0, or we say it cancels out. and that will give us x. So the question is, are these functions inverses of one another? Well, they are if when we find the composite function forwards and backwards, if they both evaluate to x, then yeah, they're inverses of one another. So unless you want to write your answer in a sentence, I'm okay if you just write yes. Why? Because the question read, are f and g inverses of one another? Yeah, that kind of looks like a yes or no response to me. In this case, yes. If you're an overachiever, go ahead, write your sentence. Yes, f and g are inverses of one another. Well, that's my time. Thanks, guys.